Okay, so this one I'm going to start off with the notes. With multi-step, you will be using more of the notes that you took in the last video. So I just put those same exact notes right here. So I'll go ahead and explain each one. So number one, simplify both sides using PEMDAS. So you will have slightly more complicated expressions on both sides of your equation. So you always want to make sure that that is simplified all the way before you start doing any work. And then make sure that your variable is on one side only. So if your variable is not on one side, you will be using the box method to get them on the side that it needs to be on. When you use the box method, please remember that that takes care of combining all your like terms. So you end up with your variables on one side and your numbers on the other. And then the last one is just isolating your variable. When you use the box method, the very last step should just be to get rid of the number that's attached to your variable. And if it's attached to your variable, it will be multiplication, so you will be solving with division, since that's the opposite of multiplication. So isolating your variable means getting it all by itself. Inverse operations means using the opposite operation. So again, if it's multiplying, you divide. And then to simplify, usually what you do is PEMDAS. So PEMDAS, please remember that the parentheses means that you do whatever's inside the parentheses. Exponents, if you see any exponents, take care of them. And then multiplication or division, if you see multiplication or division going on, you might have to distribute. It might not be regular multiplication or division. You might have to distribute the multiplication or the division, whichever it might be. So make sure we're good on distribution. And then adding or subtracting, you will be combining like terms. Okay, so let's get started with a few examples. Okay, so I tried to include every different type of multiple step problem that I can think of. So some of these you might want to write down and take step by step. So it's always a good idea to start off with your line. It helps you divide things, and then remember it's like a mirror. So whatever happens on one side has to happen on the other side, and then also when a term crosses that line, it changes. Remember, terms are always being added or subtracted, so it's going to change from adding to subtracting or from subtracting to adding. Alright, so with that being said, I'm going to reference my steps at all times, but in case we don't remember what they are, again, make sure you go back to the beginning of the video and copy these all down, because they will be helpful during this assignment. Okay, so the first one that I'm looking at is going to be 4a plus 1 equals 3a minus 5. So I'm just going to go ahead and follow my rules here. It says to simplify both sides using PEMDAS. If we look at the left side, we just have 4a plus 1. That no matter how hard you try, please make sure that you are not combining them on accident. There's actually nothing I can do here. There's no parentheses, exponents, nothing to distribute. And then yes, we have addition, but we're adding a 1 to 4a, and those are not like terms. So since they're not like terms, we leave that alone. That's just 4a plus 1. Okay, so if we can't do anything, that is fine. On the other side, we have similar situation because we just have 3a minus 5. So my left side is all clear, and then 3a minus 5, it actually has the same situation. We don't change anything. 3a and negative 5 are not like terms, so I cannot combine them. So step 2 says make sure your variables are on one side, and they are not. So if we notice, we can see that the 4a is on the left and the 3a is on the right. They are not on the same side, but I want them on the same side, so I'm going to go ahead and use the box method. So my variables I will put on the left. There are 2 of them, so I'm going to make sure that I do 2 boxes on the left. And then my positive 1 and negative 5 are the other numbers that will go on the other side. Okay, so there's my 2 boxes on the left for my variables. And on the right side, I'm going to make the 2 boxes for the positive 1 and the negative 5 to find their spots. Okay, if you don't remember how to do the box method, please pay close attention to this explanation. So my 4a, if you notice, it's on the left. I'm going to put it in that box, that first box, and it's going to stay a positive 4a because it's still on the left side. The 3a has to cross the line, so it changes from a positive 3a to a negative 3a. And so that really changes from a plus 3a to a minus 3a. Remember, we're combining like terms. Terms are always added or subtracted. My negative 5 also stays on its own side, so there I'm going to write negative 5. And then my 1 crosses the line, so it becomes the opposite, which is a negative 1. Now this is negative 1 minus 5. Okay, and if you notice, I just kind of wrote the negative 5 in the box right under it, just to make things a little bit simpler, and my arrows were a little bit clearer. It really doesn't matter because of the commutative property of addition. I can place them anywhere and I don't change the value as long as I keep the sign. Alright, now I'm just going to have my two boxes ready to combine my like terms. On the left side, I'm going to combine 4a minus 3a. So I'm just going to do 4 minus 3. 4 minus 3 should give you 1. And then make sure that you keep the a because that is their like what made them like terms. On the other side, I have negative 1 minus 5. If you need to write it on the side, you can. Notice that they have the same sign, so you add. 1 plus 5 is 6. Keep the sign of the bigger number, which is negative, regardless of what number it is. So we have 1a equals negative 6. At this point, you have a one-step equation. Usually with the box method, whatever number is next to your variable is being multiplied. So you would then divide it. Right here, I could also kind of just stop and say 1 times a is a, so a equals negative 6. But I could also do the step of dividing by 1 on both sides. 1 divided by 1 is just 1, always doesn't change anything, so I'm just left with 1a, which is a. And on the other side, I have negative 6 divided by 1, also just ends up equaling itself. Dividing and multiplying by 1 does not change anything. Okay, and our answer is a equals negative 6. So now for the next example, a little bit different. So still looking at my notes, making sure that I'm reading. The first step is to simplify both sides using PEMDAS. So here's my two sides. Make sure you write your line to make sure you differentiate between them. So on the left side, I have 7m minus 2m plus 10 equals negative 2m minus 4. Now on the left side, right there, I can already see that there's a lot more terms that I'm used to seeing, so I should be able to simplify a couple of them. No parentheses, exponents, or distribution going on, so I'm actually going to go straight to combining like terms. I can see right away that I do have like terms, and that would be my 7m and my negative 2m. When I combine these, I just go ahead and follow the operation that it tells me, so that's 7 minus 2m. And then just so we're clear, they are like terms because they have the m. The fact that one is positive and one is negative does not matter. It's the fact that they both have an m. Okay, so go ahead and do what it tells you. 7 minus 2. 7 minus 2 will be 5. And then they are like terms because of the m, so make sure that you keep the m with it. So your answer there would be 5m. Whatever we didn't touch, just bring it down so that plus 10 just comes down. On the other side, we have negative 2m minus 4, and I'm actually just going to bring that down because we could not simplify that. There's nothing more that I could do with it. If you don't believe me, just double check it for yourself. Negative 2m and 4 are not like terms. Okay, and then our second step says to make sure my variable is on one side, and right now they are not. So my 5m and my negative 2m need to be on the same side, so I'm going to draw a box on the left with 2 squares. The positive 10 and the negative 4 need to be combined together, but they're on opposite sides, so I'm going to move them to the right side. So same thing, I'm going to end up with 2 boxes on the left and 2 boxes on the right. My 5m, it's still on the same side, so it's going to stay 5m. The negative 2m actually crosses the line, so it changes from a minus 2m to a plus 2m. Please remember, we're just changing minus to addition and addition to subtraction. The negative 4 stays on its own side, and then the positive 10 crosses the line, so it's going to be minus 10 or negative 10. Okay, and then I'm just going to go ahead and put my box under each one of these to combine the two terms. So on the left side, I'm going to be combining 5m plus 2m, and on the right side, negative 10 minus 4. 5 plus 2 is just 7, and then again, make sure you keep the m. And then negative 10 minus 4, remember that they are same sign, so you add and keep the sign of the bigger number, or think of a number line. If you're at negative 10 and subtract 4, you just become more negative. And then my equation is 7m equals negative 14. We have to get rid of that 7. Remember, at this point, it is multiplying, so you have to divide that 7 on both sides. Make sure that we remember that every time we use the box method. My last step will be to divide by that number. And since I'm multiplying by a positive 7, I divide by a positive 7. 7 divided by 7 is just going to be 1. So I'm left with 1 times m, or 1m. And then that equals a negative 14 divided by 7. Negative divided by positive is negative. 14 divided by 7 is 2. So make sure that we are keeping track of our signs here. Okay. So we have the, negative 2 here. And then we are going to just simplify this a little bit. 1 times m is just m. And then negative 2 is my answer. So m equals negative 2. Just keep in mind that for the video, I am explaining a lot so that anyone who needs help can kind of come back and see these in-depth explanations every time. But I'll go a little bit faster with the next ones because the box method should be clear by now. The only thing I'm going to spend time on is now when some things change here. So for example, let me bring down my notes so that we're still able to use them. Right here we have something else going on. Hopefully you notice the parentheses right away. So again, we take our two sides and we make sure that we simplify both sides. In the case right here, I have to simplify the left side by actually using distribution because I do have something to distribute. I know I have something to distribute because I have these parentheses right here and a number right outside of it. So I'm going to take that positive 3 and distribute it to my b and my negative 2. Remember that we need to make sure that we're keeping the sign in front of the number. So we're going to do 3 times b and positive 3 times negative 2. Every time, make sure that that's how you are multiplying. If you don't write this out, that's fine, but you want to make sure that you know that that's what you're multiplying. So I'm going to multiply 3 times b is just 3b, and positive times a negative is negative. 3 times 2 is 6. So again, make sure that we're paying attention to those signs. 3b minus 6, there were nothing I could do inside the parentheses. B minus 2, that's as far as I could go. No exponents. Multiplication, I just did that with the distribution. No division, and then go to adding and subtracting, which is combining like terms. I don't have anything to combine, so I move on. On the other side, I have 8b plus 13. If you want to double check, you can, but there's actually nothing I can do here. 8b and 13 are not like terms. There's nothing else to do. No parentheses, no distribution, no exponents. So I move on. Okay, step 2, make sure that my variables are on the same side. So here I'm just going to go ahead and use the box method as I have been before. So identify your variables and identify your terms without the variables. Put them each on their own side. So I'm going to make sure that my 3b and my 8b end up on the same side, and my negative 6 and my 13 also go on the same side. 3b stays on its own side. 8b becomes negative 8b because it crosses the line. Positive 13 stays on its own side, and then the negative 6 crosses and it becomes positive 6. Okay, so the minute it crosses the line, it changes sign. Then I'm just going to go ahead and combine them. 3b minus 8b, write this on the side if you need to, but that's a positive 3b minus 8b. We have different signs, so we're going to subtract and we get 5b. Keep the sign of the bigger number, which is the 8, so it's going to be negative 5b. And then here 6 plus 13, and that's just going to be 19. Okay, and then as I've stated before, we're always just going to go ahead and divide that number that is with my variable at the end. This is just one term, so this is actually -5 times b, so I'm going to do the opposite, which is divide. So I'm going to divide by -5. Divide by -5. And I know that this one doesn't work out very nicely, but that's okay. Negative and a negative make a positive. 5 divided by 5 is 1. And then the b, I don't do anything to it, so it's still times b. Positive and a negative is a negative. And then 19 divided by 5, I'm actually just going to leave as a fraction. I could turn it into a decimal. Either way is correct. Positive 1 times b is just b, so b equals -19 over 5. Okay, just because it's a fraction doesn't mean it can't be an answer. So we move on to the next problem. Pause if you need to look at a problem a little bit more. Okay, so still following my steps, I'm going to go to each side and simplify. So here I'm going to make sure that I simplify the left side all the way before I move to the right side. Alright, so inside parentheses, q plus 4 can't do anything. Q plus 2 can't do anything. Moving on, exponents, don't see any. Moving on, multiplication, yes, I can definitely distribute. I have here my parentheses, which tell me I am distributing the number that's right outside. And the number that's right outside is -2. So I multiply -2 times q and -2 times 4. And then I will notice here that I have another distribution, but we'll get to that in just a second. I'm going to do this by parts. So -2 times q is just -2q. -2 times +4, negative and a positive make a negative. 2 times 4 is 8. And then just drop everything down that I haven't used. So this whole thing, I'm just going to drop it down here. So it's +3 times q plus 2. Okay, I'm going to keep going on the left side before I do anything on the right side. So the next thing I want to take care of is any other distribution that I see. So again, I see parentheses here and a +3 right on the outside. So I'm going to distribute that. When I distribute that, I get a +3q. 3 times q is just 3q. And then a positive times a +2. That's going to be positive, and 3 times 2 is 6. Anything that I haven't done anything with, I just bring it down. So -2q minus 8, I'm just going to bring down. Okay, this is not simplified all the way yet, so I would suggest simplifying it here instead of waiting for the box method. So that for the box method, you only have like 2 switches to do instead of 3 or 6 or whatever it might be. Alright, so you always want to make sure that you are combining your like terms. When they're on the same side, you just go ahead and do whatever they tell you to do. So -2q plus 3q, those are like terms. -8 plus 6, those are also like terms. So I'm actually going to rewrite it just for our sake. -2q plus 3q. Make sure you combine those. And then -8 plus 6, and make sure you combine those. -2 plus 3 is just +1 because they're different signs, so I subtract and keep the sign of the bigger number, which is the 3. The q is what they have in common, so it stays there. -8 plus 6, different signs as well, so I'm going to subtract and I get 2. Keep the sign of the bigger number, which is negative, so that's going to be 1q minus 2. And I'm going to get all the way to the bottom here and say that that is just q. +1 times q is just q minus 2. Okay, so now that I simplified the left side, I'm going to actually go to the right side now. On the right side, inside the parentheses, -7 plus q, I can't do anything. No exponent, so I move on to multiplication, which is distribution. Here are my parentheses. Here's the number that I need to distribute. -4 gets distributed into -7 and +q. A negative times a negative is a positive. 4 times 7 is 28. Negative times a positive is a negative, and 4 times q is 4q. Sorry, don't know why I wrote it with that color. So let me just rewrite it. Okay, can I do anything else here? Well, these are not like terms, so I can't. I'm just going to bring it down to the bottom of my equation to line up with my left side. So positive 28, I don't really need the positive there. Minus 4q. Alright, so this is what I'm left with. So that was actually just within the first step, simplifying everything. And then second step, get my variables on one side. This is where I use the box method. So my q is here, but my negative 4q is on the other side. I need to get them together. The negative 2 needs to combine with the 28, so I need those together. Okay, so I'm going to do my box method. 2 boxes for my variables, 2 boxes for my numbers. My q stays on the same side, so it's just there. The negative 4q changes because it crosses the line to a plus 4q or a positive 4q. 28 was already on that side, so I'm going to leave positive 28 alone. And then negative 2 crosses the line, so it becomes positive 2 or plus 2. Okay, and then we just go ahead and combine our like terms here. Remember that whenever you have a variable by itself, that is one variable. So there's always a 1 there for us to use when we're combining like terms. So that's 1q plus 4q. That means 1 plus 4 is 5, so I'm here with 5q. 28 plus 2, that's 30. There's no negatives involved, so that one's pretty easy. And then just get rid of the 5. The 5 is always, the number at the end is always being multiplied with your variable, so I divide by 5. I multiplied by a positive 5, so I divide by a positive 5. 5 divided by 5 is 1, positive 1, so I'm left with 1q. And then 30 divided by 5 is 6. So I'm left with q equals 6. Alright, and I know that it seems like a long example, but all it was 3 distributions, combining like terms, and then the box method. It was just mostly explaining than anything else. Okay, 2 more examples just so that we are good and ready for any type of problem. So this one's a little bit simpler. I'll go a little bit faster with it because you have seen me distribute so many times. So I'm going to distribute that negative 4. I've already checked that we can't do anything else because nothing can be done inside the parentheses, no exponents. So we go straight to distribution. Negative and a negative is positive. 4 times 2 is 8. Negative and a positive is negative. 4 times r is 4r. At this point, I can't change anything. There's nothing else to do, so I go to the other side. On the other side, I also see my parentheses and that I need to distribute a positive 3. When I distribute the positive 3, that's positive times a positive. I'm left with a positive. 3 times r, 3r. Positive times another positive, it's positive. And 3 times 5 is 15. Always make sure that we're keeping note of our signs. Alright, so now I'm going to combine my like terms. So my negative 4r and my positive 3r need to be on the same side. My 8, my 8 and my 15 also need to be on the same side. So I'm going to go ahead and do my box method. 2 boxes for my variables, 2 boxes for my numbers. Okay, this one I'm going to do a little bit different just for convenience purposes. So my negative 4r, I'm going to put in the first box. The positive 3r crosses the line, so it becomes negative 3r or minus 3r. I only did that so my arrows don't get too confusing. Positive 15 will go in the right side, and then my positive 8 crosses the line, so it becomes negative 8. Make sure that we are adding and subtracting correctly. So combine them. That's a negative 4r minus 3r. If you need to write it on the side, you can. These are same sign, so I need to add. So 4 plus 3 is 7r. But keep the sign of the bigger number, so that's negative 7r. Negative 8 plus 15, different sign, so I subtract. 15 minus 8 is 7, and keep the sign of the bigger number, so that's going to be a positive 7. All right, the last thing you need to do is get rid of that negative 7. Remember that there's always multiplication here at the end when our variable is all by itself except for that number. So we're always going to divide the number that's attached to my variable. Divide by negative 7 on both sides because that's what I was multiplying by. Negative and a negative is a positive. 7 divided by 7 is 1. And my r didn't do anything to it, so it's still there. Negative and a positive, or sorry, positive divided by a negative is negative. 7 divided by 7 is 1, so I'm left with negative 1 on the right side. Positive 1r is actually just r, and that equals negative 1 right there. And the last example, it's going to be a little bit of a lengthier one, but as I said, we've done so much work, so it shouldn't actually be that bad. So again, you can check your parentheses, you can check everything, make sure that there's nothing else to do, but I'm going to go straight into the distribution because I know there's nothing else we can do. So that negative 2 needs to distribute into this group, or this parentheses. If you want to do distribution all at the same time, you definitely can. Like, I could go over here and say I'm also going to distribute the positive 2 into these two parts. So if you want to do them all together, you can. It's not going to stop you from everything. Just make sure you keep track of everything. So this is going to be a negative 2 times a positive y. Negative and a positive is negative. 2 times y is 2y. And then we have negative 2 times negative 8. A negative and a negative make a positive. 2 times 8 is 16. Okay, now that that's done, without messing anything up, you can go straight into the other distribution. Positive 2 times positive y, it's going to be positive 2y. Positive times a negative, we have negative, and then 2 times 3 is 6. Okay, and then here, we're not done, so we want to make sure we combine our like terms on the same side. So whenever we can, we are going to combine like terms that are already on the same side. We only use the box method when they are on different sides. Okay, so my negative 2y plus 2y, please make sure we are thinking about this. So we know that the y is always the like term, but also think about the fact that we have a negative 2 plus 2. So normally, if I have a number line and I do negative 2, start at negative 2, and then add 2, I'm going to jump 2 times, and I'm going to end up at 0. So that's actually what's going to happen here, is that I'm going to end up with 0 of these. You can also look at the fact that they are different signs, so I subtract, and then 2 minus 2 is 0. No matter which way you figure it out, it will be 0. But the other thing that you want to keep in mind is that anything minus itself, or whenever you are adding opposites, they will equal 0. So, for example, or not for example, let me write this a little bit clearer. So I didn't highlight these other ones, but those are also like terms. So I have negative 2y plus 2y. I'm just going to rewrite them together just to keep track of everything. Notice that I kept all the signs where they were. So right here, you could tell me that that is 0y, but eventually you need to realize that that is 0 times y, and 0 times y is just 0. So I would much rather you be able to tell me that it is 0, because at this point the y doesn't matter that it was there, because they canceled each other out. Alright, and then combine those. Positive 16 minus 6 is actually positive 10. And then 0 plus 10 is just 10, so that's what I'm going to write on my left side once it's all simplified. 2y minus 2, there's nothing else I can do, so I'm just going to bring that down. There's nothing else I can do to simplify it. Now at this point, you could use the box method, but you don't have to, because my variable is actually already on one side. It just happens to be on the right side. So I can actually use my steps for two-step equations and get rid of that minus 2 first by adding. So add 2 on both sides, and I end up with 12 equals 2y. When I do that, I'm left with my one-step equation. Remember, I always said the last step is usually, not always, but usually going to be to divide whatever number is with your variable. So since that's 2y that is being multiplied, and I divide by 2. Divide by 2 on both sides. 2 divided by 2 is just 1. So I'm left with 1y. And then 12 divided by 2 is 6. So I have 6 is equal to y, or y equals 6. Either way, your answer is the same.